Okay guys, this is the kind of last review video for the Unit 5 test. Gonna go through the key things you need to know. This isn't necessarily like everything, but like these are absolutely the main things you need to know. Talk about the FRQs a bit. This is what I'm going to be doing in class on Tuesday, so if you missed Tuesday or you want a refresher of what we did on Tuesday, this is the video for you. Okay, so what do you need to know? All the core derivatives and the derivative rules. So what that's referring to is on the practice test. It's just saying all of these, all of the derivatives, all the derivative rules. You gotta know them. Okay, that includes L'Hopital's. So a reminder, you should know these. You should know these four, right? Just off the top of your head. This is 1 over x. This is 1 over x ln a. This is e to the x, right? And this is a to the x ln a, right? So you should know all the derivatives. Next, implicit differentiation, you should know how to do it, right? That's delta 5.3 if you need a refresher. How to do it at a point, derivative at a point, how to find a point of a tangent line, how to write a tangent line, how to find the second derivative, and I'll be going over those later in this video. For mean value theorem, you need to write how to write the sentence. I'll talk about that in a bit. Finding C with a table, I will also do that. How to find C with a calculator, this is all in, some of this is in practice test. And then some of that is delta 5.4. Okay, so be very familiar with how to do that. Average value, know the formula and know that it's different from average rate of change, right? So make sure you know AROC is f of b minus f of a over b minus a, and that's giving you the average rate of change of a function. So basically, in AROC, you're going from a function to a derivative or to a slope. Does that make sense? I don't like the way I wrote that. You're going from a function to a slope, if that makes sense. You're changing units. But in average value, it's just think of it like you're finding the average heights of a bunch of different heights. You know what I mean? The value itself is not changing. It's still in the same units. 1 over b minus a integral a to b of f of x dx. So it's staying in the same units, if that makes sense. This is average value. That's average rate of change. Know the difference, and know how to write the integral, find it with the calculator, explain the meaning of a sentence, and get the integral from the average value. What this last one is referring to is the idea of like saying, if I know the average value between 2 points is this, then what's the area? And to do that, if I give you the average value, you just multiply by the width, by the b minus a, and that will get you the integral, if that makes sense. Okay. Should I do like a problem that, I'll do that problem like really quickly. Basically, if I say average value between -1, 3 is 8, what's the integral from -1 to 3 of f of x dx? Well, because I know the average value is 8, that means it must be 1 over 4 integral 1 to -1 to 3 f of x dx must be 8. So then I can just multiply both sides by 4. Therefore, the area must be 32. Okay, that's what that means. Okay, power rule. These are like, I mean, this is review. This is stuff from Unit 2, but these are just like common power rule derivatives that people struggle with. The first one, square root, just memorize this, guys. Just memorize this. This is 1 over 2 root x. Just memorize that. Yes, you can go, oh, you can say, oh, that's x to 1/2, and so that's 1/2 x to -1/2, and so on, right? But it's just better to memorize that, and that is the same thing as this, right? But it's in your best interest to memorize it. Okay, derivative of x is 1. Okay, often see that one as mistake, even though it's easy. Derivative of x, -1. Don't get tripped up by that. Derivative of 2 over x. See this all the time. People get tripped up on this. All right, make sure if it's in the denominator, bring it up. This is really the same thing as 2x to -1. So we differentiate that. We're going to get negative 2x and negative 2, which is negative 2 over x squared. Okay, so be familiar with that. The same thing here, 1 over x squared, that is the same as x and negative 2, which will become negative 2x and negative third, which is negative 2 over x to the third. Right. Last one, the fourth root of x to the third, that is the same thing as x to the 3/4, which is going to be 3/4 x to the negative 1/4. And so simplifying that, that is the same as 3 over 4x to 1/4, which is the same as 3 over 4 fourth root of x. Okay, so just like a little bit of review, kind of a hint, guys, kind of a hint of what, some of the derivatives you might see on this test. Kind of giving you a bit of a hint here. Just be familiar, make sure you're familiar with these 6, okay? And like how to get those kinds of weird power rules. All right, let's go over some FRQs. So FRQs, first one we got implicit differentiation. Just so you're aware, like implicit isn't like one of the big 6. It's pretty frequently on the AP test, but it's not every year. It was on the 2023 test. So it's good to be aware of it. It's kind of on there like every other year, kind of once every 3 years, kind of along that lines, not necessarily every year like some of the other problems are. So it's definitely an important one to know. And if it's not on an FRQ, it's definitely on an MCQ. So here's like how generally these problems work. Usually they'll give you the derivative. So they'll tell you what the derivative is and they'll say show that it's true. And so for these kinds of questions, you implicitly differentiate, which you know how to do, and just show that your solution equals theirs. Right, and that's usually this is like 2 points usually doing that. And then here, this is a very common question. I see this all the time on the implicit FRQs. It's asking for a point where the tangent line is. It could be horizontal, it could be vertical, or it could be a specific value. And for these, you follow the sort of same steps for each one, but with a slight little difference. And the difference comes in the first step. So if it's a horizontal tangent line, right, that means that it's horizontal, right? It's flat. That means you just set the numerator equal to 0, and you solve for the variables. And you may need this is in the practice test. You may need to sub a variable back into the original function to solve for the other coordinate. But otherwise, it might give you a coordinate. We'll talk about that in a bit. And then you make sure it works in the original equation. So check it in the original equation and make sure it's true. And if you want to check your work, you just plug in the coordinate back into dy dx. You should be getting 0, and when you plug it back into the original, it should just work, right? It should be true. Vertical is very similar, except it's a denominator. So this is the numerator is 0, but it's a vertical, right? What that's saying is, it's going like straight up like that. Okay, this one's going horizontal. This one's going straight up and down. You set the denominator equal to 0, and everything else is the same. You set the denominator, the derivative equal to 0. If it's a number, you just set the whole derivative equals that number. So these are like the three different ways, three different values, 3 different things. Okay. You need to be able to write your equation of a tangent line using the derivative, which is just the formula that you know, y minus y1 equals mx minus x1. And you will get m by plugging in that coordinate into the derivative. Sometimes it might just give you the x, in which case you plug that into the equation to get the y, right? And once you have the x and y, you plug in the derivative. That's how that works. And lastly, the second derivative. I can tell you right now, on the test, 100% on the test, you will have to take the second derivative on the test. Okay, so make sure you understand how to do this. Make sure you have your coordinate ready to go. If it tells you to have a coordinate, make sure you know it. Usually they give you dy dx. So just use theirs. Even if you couldn't answer this one up here, like you struggle with that, that doesn't stop you from answering this question, because you can just use theirs. I'll talk about that in a bit when we do a problem. And then implicit differentiate using quotient rule. Pretty much, I don't know many examples where you would not be using a quotient rule. You're just going to differentiate again. You're going to have to use quotient rule. And then you're going to plug your point into dy dx, and you're also going to plug it into the derivative, and you're going to sub everything in to the second derivative. Okay, let's do an example problem, because it's one thing to talk about, but it's another thing to do it. Let's do one. It's another one. This is from 2004, number 4. The average score in this, by the way, was a 4, which is pretty high. was a 4 on the test out of 9. That's relatively high for an FRQ problem. Usually it's around like a 3. So first thing, like I said, is just like show that the derivative is this. Okay, so when it says show the derivative is that, you just do it. You just implicitly differentiate this. So we're going to get, when I implicitly differentiate, 2x plus 8y dy dx. I'm also getting flamed so much from my handwriting. I'm going to make this, I'm genuinely just going to try my best, guys. So bear with me. Equals, that's going to go to 0. And then we have a little mini product rule here, right? Lefty right, 3x dy dx plus 3y. All right, that's a little mini product rule. Make sure you don't miss that. That is a common thing to miss. Product rule, don't forget. Okay. Then we just follow normal steps. We're going to get the dy dx as alone on one side. So let's move the 2x over, minus 2x, minus 2x, minus the 3x dy dx, minus 3x dy dx. And so when we simplify it, we're going to have 8y dy dx minus 3x dy dx equals 3y minus 2x. And you can see, look, already I'm getting pretty close to here. Last step, we factor out the dy dx. 8y minus 3x equals 3y minus 2x. Last step, we divide by the factor term, 8y minus 3x, 8y minus 3x. So it's true. When I factor it out, this equals dy dx. I mean, you should probably, I kind of ran out of space here, so you would do this like on another line, right? But that's it. I showed it, right? I showed that the derivative, I implicitly took the derivative, and I'm showing that my derivative is the same as this, right? See, like it's the same thing. That's all you're doing, okay? B, show that there is a point P, all right, with x coordinate 3. All right, that's important. X coordinate 3, at which the line tangent to the curve P is horizontal. Find the y coordinate of P. Okay, so what this means is that I have a coordinate 3 comma some y. I don't know what the y is right now, but it's telling me that at this point that the line tangent is horizontal. So remember what I just said about this, about the horizontal line? If the tangent line is horizontal, what's true about the derivative? The derivative equals 0. So if the derivative equals 0, right? Let me write this out in steps. If the derivative equals 0, that means that 3y minus 2x over 8y minus 3x, that means that must equal 0. But more specifically, when you set something equal to 0, the denominator doesn't matter, right? It's only the numerator that matters. When the numerator is 0, the function is 0. That's not true for the denominator, okay? That's for vertical. So we set the numerator equal to 0. And then, since I know it gave me that the x was 3, so I'm going to say 3y minus 6 equals 0. 3y equals 6, divide by 3, y equals 2. Okay? When I put in 3 into this, is what I did here. That's not clear. 3 times 2 is 6. Right? What I'm doing here is x equals 3. And I plugged it in. And then I solve for y. That's this step that I was talking about here, where you set it equals 0 and solve for variables. That's what we just did that. We solved for the variables. Okay. So I know that the y is 2. So I know really my coordinate here is 3, 2. But there is one more step. I need to show that this exists in the original equation. That's the last step. That's this step right here. Make sure it works in the original equation. So it works in dy dx, like I just did it in dy dx, like it's true. But now I need to make sure it works in the original equation. So the original equation was x squared plus 4y squared equals 7 plus 3xy. So I'm just going to plug in a a 2 and a 3 into that. So I'm going to get down here, it's going to be 3 squared plus 4 2 squared equals 7 plus 3 times 2 times 3. I'm just plugging in x and y into the original. So I'm going to get 9 plus 16 equals 7 plus 6 times 3 is 18. And these are the same thing, because this is 25 equals 25. So I'm good. Therefore, 3 comma 2 is a point on the curve. Therefore, p equals 3, 2 is on the curve, and slope equals 0. Okay, that's it. The difference was with the practice test problem. Just to give you context, there was a very similar problem on the practice test, and I just want to like kind of compare these two problems so that you are aware that they're really similar. In the practice test, let me jump back to that for a second. You had a very similar first problem, just show that that's true. And then the second problem was very similar. Find the coordinates of the curve which tangent line is horizontal. So the same idea, set it equal to 0. The difference with this one is that it didn't give you any coordinates. It told you no coordinates, and you had to just get it from the derivative itself. Luckily, the numerator was just a y, so it just told me that y is 0 from that. And then I took that and plugged it into the original to get the value, but it turned out that it didn't work, so there was no solution. Okay, so that's this one. And C was very similar as well. It's just that where it was vertical, and that was the same thing. You set the denominator equal to 0, which is what's going on here, and then you plug that back into the original to solve for the variable. Okay, so just review the practice test. Now with this context, I would go back and look at the implicit problem on the practice test. Okay, last one. I told you this was going to be on the test. This is going to be on the test. Find this value of the second derivative at the point P found in part B. Does the curve have a local maximum, a local minimum, or neither? Point P, justify your answer. Okay. So luckily I have my point. I have 3, 2. Like I know the point. This is P. So it's like find the second derivative here at P. So we're going to go back to there. So again, if you didn't get this, you can still use the one that they gave you, right? And just because let's say you couldn't find point P, that's okay. You can still get points just from taking the second derivative. So again, don't give up just because you couldn't do an earlier part. Like still try and engage with it and try and do it. Take the second derivative. Let's take the second derivative. So I'm going to go back up here. I'm going to rewrite it. Okay. So dy dx equals 3y minus 2x over 8y minus 3x. This is going to be, right, you can see a quotient rule, right, because it is a quotient. So d squared y over dx squared equals low 8y minus 3x d high 3 dy dx minus 2 minus, I'm going to rewrite it, guys. This is like embarrassingly messy. I'm just going to rewrite it down here below. Okay. Low. I am going to take my time. I'm rushing. I don't know why I'm rushing so much. I just need to relax and take my time here. Like I would tell you. I would tell you just relax and take your time. I'm not rushing. Okay. All right. Here we go. Low 8y minus 3x d high 3 dy dx minus 2 minus high 3y minus 2x d low 8 dy dx minus 3 all over the low squared 8y minus 3x squared. Okay, so at point, so that's by the way, this is 2 points. This right here, me finding this, that's plus 2 points. So that's really good. Just finding the second derivative, that's 2 points. Now we have to find it at a value. So we're trying to find it at p equals 3, 2. What you're going to do is you're going to take this and plug it into all the x variables here. Here's the thing though, guys. We know from above here that dy dx at the point 3, 2, what was it? Remember? The derivative, we just did it right here. This is the coordinate where the slope is 0. So you know that the derivative there, if you were to plug these points into the derivative right here, you'd get 0. So I know that wherever I see a dy dx here, that's really a 0. Okay, so now you just plug them in. So it's going to be 8 times 2 minus 3 times 3 times 0, because it's 3 times 0, minus 2. Okay, minus 3 times 2 minus 3 times 3 times negative 3. Because that's a 0. Again, 0 all over 8 times 2 minus 3 times 3 squared. I know this sounds wild right now, but technically this is fine. Like, I know that seems crazy. Like, you're like, what? How can I do that? You can. This is acceptable. Like on the AP test, that would get you right now 1 point for doing that. However, you kind of need the value to answer the next part. So once you simplify this, you should get negative 2/7, and this like will help you answer the last part. So the last part's asking, well, does the curve have a local max, min, or neither at point P? And this is actually a review of something from last test that I kind of very briefly covered. People didn't really get it. This is called the second derivative test. I'm going to review it now. Second derivative test says if the first derivative is 0, okay, and the second derivative is greater than 0, then you must have x must be a relative min. Okay? If the derivative of x is 0 and the second derivative is negative, concave down, x is a relative maximum. That's what the second derivative test says. So the logic here being, if it's concave up like this, look, that's concave up, right? And I know that it's a tangent of 0. It has to be a relative minimum, right? See that? Similarly, for the relative maximum, if it's concave down and I know the tangent line is 0 like this, it must be a relative maximum. That's the idea. So since here, look, my second derivative is negative. My first derivative is 0. So the position I'm in right here is the second. So you say, since dy dx is 0 and the second derivative, d squared y dx squared, is less than 0, p must be a relative maximum. I would say, scratch the p, there must be a relative maximum at p. It's very similar, but I prefer that language more. Okay, that's the second derivative test. So that is that problem. Okay, that's implicit differentiation. That's another problem for you. If you want to go over the one on the practice test as well, that's good. Also, just like, you can just Google it, go on YouTube and just search implicit differentiation FRQ, you know, practice. Go on YouTube, go watch the videos. They'll help you too if you're still stuck, but hopefully you're fine. MVT and FRQs. So there's very frequently an MVT question on the FRQs, and if it's not on there, it's on MCQ. This is the kind of flow chart. You always got to check the conditions, make sure it's differentiable and continuous over AB and AB. We'll talk about that in a bit. Remember that if a function is differentiable over an interval, it's also continuous over the same interval. So if I know that it's differentiable over closed AB, then it's good. Okay. And usually it won't try and trick you too much with this. From what I see, like it's pretty straightforward. If f is different, this is basically what you write. F is differential, therefore it's continuous. That means therefore. This little arrow just means therefore. Over AB, so we may apply the mean value theorem. Perfect. Okay. Then you check the average rate of change and make sure that the derivative that you're looking for is there. If it's not, like on the big interval, you check the intervals in between, right? And make sure you show your work really accurately and clearly and write the formula correctly. Okay. And then you want to write this sentence. Therefore, by the mean value theorem, there must be a C for a less than C less than B, such that the derivative of C is the AROC. Okay, so let's do a problem. This is like part of I'm not even sure which one this is from, but it's just A from one of the FRQs that had this. Velocity of particle is shown above, where Vp of t is measured in meters per hour and t is measured in hours. Selected values of velocity are shown above, and its position is at the origin at t equals 0. Justify where there must be at least one time t between 0.3 and 2.8 in which the derivative of the velocity, the acceleration of the particle, equals 0 meters per hour per hour. Okay, so for this problem, okay, sorry. For this problem, let's first check the conditions. So how do I know to use the mean value theorem here? That's like kind of the first part. How do I know to use the mean value? Well, because I'm given I'm given velocity and it's asking about the derivative of velocity. So because it's giving me velocity and then it's asking me about like its derivative being a certain value, that tells me MVT. So right, does that make sense? So it would be intermediate value theorem if it was asking about like if it was asking just about the velocity, that would actually, if it was asking about um, the velocity being a certain value, that would be intermediate value theorem. But because it's, let me kind of like mark that down below. If it said, if this was, if it was like, does velocity equal 3, that is going to be IVT, or intermediate value theorem, because I'm given velocity, right? Because what it's asking for matches what I'm given. Like, does that make sense? Asking equals given. That's IVT. Since it's saying, essentially what it's saying is, does acceleration equal 0? That's what it's saying right here, right? And this is MVT. I know this is MVT because what it's asking is the derivative of what's given. The derivative of f of x, right? Asking is given. It's asking for f of x, right? And I'm given f of x. Here it's asking for the derivative, right? And I'm given the function. Okay, it's asking for a slope. This is asking for a value, that's asking for a slope. Okay, I hope that's clear. If not, like, again, lots of other resources out there. Just Google IVT, MVT, FRQs, and you'll get more stuff on this. So conditions. I know this is MVT because of the situation. It's asking about the acceleration. I'm given velocity. Okay, so conditions. Is it differentiable? Yes, it is. Look, it says it. It's a differential function. So you say, and make sure you use the right letters. Don't say P. Don't say F. If it's VP, say VP. Don't say f of x. VP is differentiable, therefore continuous on 0.3 to 2.8. And then, so we can use the mean value theorem. We can use the mean value theorem. Okay. Now I'm on step 2. Get the AROC. Let's get the AROC. So it's going to be from 0.3 to 2.8. And sometimes you can just you'll just see it. See how 0.3 to 2.8, see how it's the same y values here? That means the slope is 0, right? So I can see it. Okay, f of 2.8 minus f of 0.3 over 2.8 minus 0.3 equals 55 over 50 minus 55 over 2.5, which is just 0, right? So therefore I can say, therefore, by the mean value theorem, there must be a t. This is also important. It must be a t for 0.3 less than t less than 2.8, such that the derivative of no, not f. It's fp prime t equals 0. So one thing I want to make clear here, and I'll spend a second going over, is that make sure yes, this is the sentence structure, but make sure that just to match the notation of this. So in this our f was VP, right? So that's why I said VP is differentiable. I'm continuous on that. We can use mean value theorem. Then I took the arbitrary change. Therefore, by the mean value theorem, there must be a t. I said t because it was asking for a t. See here, why there must be with one time t. See, I matched it to that. That was our c, if that makes sense. That's why I caught myself at the end here. I was about to say the derivative at t. No, it's the acceleration at t, or the derivative of v of p, vp at t is 0. Okay. Last one. So this is one that we've been going over kind of for almost, this is the third unit in a row almost we've been going over this kind of problem. Accumulation, average value. All right, we've looked, this is kind of rate in, rate out. These are kind of the same thing. Rate in, rate out, and this are very, very similar. And this is like the bread and butter of calculus, right? Once you understand these questions, and I have to say I love these questions, these context calculator questions on delta. Just crank these out. Crank these out. Just do these problems. Know how to do those calculator context questions on delta, right? You read the question very carefully. You write notation perfectly. You never forget dx or dt. You always include the time in the explanation. You always are very detailed. You always have to say at a certain time. You understand how units change with integration differentiation. You always show with notation what you're doing in the calculator. Values, I should never be where did this value come from? I should know where the value came from. If it was an intersection of a point, you have to tell me, okay, I'm finding that intersection point. You can't just say, oh yeah, this is this random value. And this is basically what a repeat of what I just said in the previous one. If it says VPT, you say VBT. You do not say F, right? You have to match it to what it says. And these are these are some pretty classic ones. Actually, I'll add one at the bottom that I kind of forgot about. I didn't forget. I didn't do. So like it might say rated instance, and like that's the derivative, and so you get the derivative of that, and like this is an explanation of what it might look like. It might be the average rate of change, in which case you'll use the average rate of change formula. It might be the average value of a rate or average value of a thing, and so you'll use the average value formula. It might say, is the rate increasing or decreasing? That is the second derivative, right? This is second derivative. All right. All right. This is usually this is like the first derivative or the rate. It's dependent. Like it's not always the derivative. It depends what you're given. Because if I'm given the rate, well then this is me just plugging it in, right? You see what I'm saying? I don't need to differentiate that. It's all dependent on what I give you. If I give you quantity, in that case, it's the derivative. But if I give you the rate already, you don't need to take the derivative. Does that make sense? Increasing or decreasing, like that would be the second derivative. If I give you quantity, it would only be the first derivative if I give you the rate. Let me like explain that here, right? So there's basically three things you can have. You can have quantity, rate, and then like rate of rate. And so like in units, right, we might have like pounds, and then here we might have pounds per hour and pounds per hour squared. What did I say about handwriting? If I give you quantity and I want the rate, yeah, you're gonna have to take the derivative, right? But remember, this is differentiation, differentiate, and this is integrate, right? Yeah, if I give you quantity, you're gonna have to take the derivative to get the rate. But if I give you the rate, you don't have to take the derivative. You see what I'm saying? So you have to kind of know where you are on this like chart and know where to go from there. If I want the quantity, which I actually didn't include on here, that was the thing I said I wanted to go over, you're going to have to integrate that to get the quantity, right? If I want the future value, you know what, let me take a moment just to do those. I want to go over those. So the other two that I didn't really cover, I've got rate increasing, decreasing. I'm going to talk about this one in a bit because I'm going to do a problem like this. But the other two I didn't cover are like quantity in or out over some time. That's an integral. It's either the integral of like the rate in from A to B, or the integral of the rate out. And that was something I saw a lot on the test that you all missed. Like you struggled with this. Oftentimes, there was a question on the last test that asked for like the quantity that entered in a given time, and a lot of you just added that starting value for no reason, right? If I want like a quantity at a time in the future, that's when you do that, right? If I want the quantity at the time in the future, you need to take, that's when you take the starting value and you add the integral of any rate in minus rate out dx, right, from A to B. Okay, so these two, I'll probably make another printout just for these two, but those are another two that come up quite a lot. Let's do some problems. Let's do some work here. So 2022 number 1, calculator aloud. From 5 a.m. to 10 a.m., the rate at which vehicles arrive in a plaza is given by A of t. Okay. And A of t equals 450 root sine 0.62 t, where t is the number of hours after 5 a.m. and A of t is measured in vehicles per hour. Traffic is flowing smoothly at 5 a.m. with no vehicles waiting in line. Write but do not evaluate integral expression that gives the total number of vehicles that arrive at the toll plaza from 6 a.m. to 10 a.m. T equals 1. Luckily, it's pretty nice if you do t equals 1, t equals 5. So again, this, if we think about this is what I just went over. This is it. The quantity in or out over some time. That's it. And that's the integral of the rate. So all I have to do here is take the integral of that rate, which I don't even need to write. You can just write the symbols for it. And don't forget, whatever you do, do not forget the dt from 1 to 5. And I know that seems too easy, but that's it. That is all it is. Okay? Right? But do not evaluate an integral expression that gives the total number of vehicles that arrive. I'm done. Right? There's no starting value. I don't need a starting value. Even if there was one, there would not be one in here because it's just the number of vehicles that arrive, not the ones that were already there. Okay? Average value of the rate in vehicles per hour at which vehicles arrive at the toll plaza from 6 to 10. Okay. So for this one, okay, on to B. Find the average value of the rate in vehicles per hour which vehicles enter the toll plaza from t equals 1 to t equals 5, 6 to 10. Okay, so here this is the average value formula, right? 1 over b minus a integral a to b f of x dx, right? The function. So you write that. So we say average value equals 1 over b minus a, 5 minus 1, integral 1 to 5, a of t dt. Do not forget the a of t dt. And this, you're doing on the calculator, right? This is where you plug it in for y1. So we're going to plug in 450 root sine 0.62x close, done, math 9, y1, clear that, math 9, y1, comma, x, comma, 1, comma, 5, close it, and then don't forget at the end of this, divide it by, what are we going to divide it by? What's 5 minus 1? 5 minus 1 is 4. So just going to wait for this to load, and we're going to divide that by 4 when it's ready. Okay, good. Then divide by 4. And we're going to get 375.537. 375.537. So again, like a nice like sentence here. It doesn't seem to specify to write a sentence, and I think you would get full points for this, but a sentence would be like the average rate at which vehicles arrive at the toll plaza from 6 a.m. t equals 1 to 10 a.m. t equals 5 is 375.537 vehicles per hour. And again, the key thing here, remember, the units don't change. I'm taking the average value of vehicles per hour. I get vehicles per hour. It's the rate, they stay the same. Whereas this one here would have just gotten me a quantity of cars, right? Okay. Okay, just so you know, on the grading scale wise, I want to grade these. This is a point for saying the correct formula here. That's like a point, and then this is a point right here for just getting the value. Okay, that's that. This is just 1 point right here. Okay, and then the previous one. Okay, let's just keep going. We'll come back to that. Okay, C. Is the rate at which vehicles arrive in the toll plaza increasing or decreasing? You gotta just read the question really, really carefully. Is the rate increasing or decreasing? Is the rate increasing or decreasing? Not are there more cars going in than going out, right? It's not about how many cars are going in. It's about are the amount of cars going in increasing or decreasing, right? Think of it that way. It's saying, are the amount of cars going in increasing or decreasing? So remember, let's think about this for a second. A of t, when I plug in A of t, like a specific time, it's giving me how many cars are entering, right? That's what it's saying at that time, as a rate, right? And I want to know, is that going up? Is my rate going up? Right? Well, if it's going up, what must be true? What must be true is that the derivative must be positive if it's going up. Or if it's negative, right, it's going down, right? And if it was equal to 0, it wouldn't be changing at all. Okay, so we need to find the rate of the rate. This is, think about the previous question, previous like things here. It's this one. Is the rate increasing or decreasing? Derivative of the rate. Okay, so we say for this one, we need to find a prime of 1. So we're going to math 8 this. Math 8. y1 comma x. Oops, comma x. Can't really see that, can you? Comma 1. And I get 148.947. It's really important when it says give a reason for your answer. We got to give. This alone is not enough. This is getting a point right now, right? I'm getting 1 point for this, but I need to get my other point. So I need to give my reason for my answer. Well, because this is positive, I can say because a prime of 1 is greater than 0, the rate at which vehicles are arriving is increasing. Okay, that's my other point. Okay, and now it's just key things here, guys. Notation matters. This little thing matters. Not a prime of t, a prime of 1. At t equals 1, t equals 1. That's so important. The time matters. Okay. In fact, it's good practice just at the end of this to say at t equals 1. Get in the habit, always be mentioning the t. Always be mentioning the t, okay? Last one. This is from a different question. This is not the same question, by the way. This is like a different problem. This is from a different year. Okay. The density of bacteria in a petri dish for 1 to r is modeled by the function this. At what value k from 1 to 4 is g of k equal to the average value? Okay. This looks like a complicated question. What it's asking is, when is the function equal to the average value? That's what this is saying. For what value k between 1 and 4 is the function g of k equal to the average value? So to do this, we need to find the average value, right? We have to find the average value. So average value, again, we just did this, but average value, you write it just like we did, would equal 1 over 4 minus 1 integral 1 to 4 of g of r dr. Same thing, keep the units consistent. Units need to be consistent. So we're going to put that in. 2 minus 16 cosine, parentheses, cosine 1.57. I sorry, this one is just like testing your ability to write something in a calculator. Root x, close it, let me read this right, close it again, and raise it to the power of 3. Okay, I had to pay attention to that one. So let's do it. Math 9, y1, comma x, comma 1, comma 4, close it. and then divide it by 3, 9.876. Okay, so that is 2 points right there. So again, just finding the average value, that's 1 point. Like considering this, like this definite integral right here, that's plus 1 point, and this right here is another plus 1 point, just for getting the answer, plugging in the calculator correctly. Then we just need to find out, okay, well, when does the function equal this? So it's very similar to finding the c in these problems. If I go back here, this is like for what value c does the IROC equal to the AROC? For what value does f of c equals the average value? It's very similar to that. You know, with this one, you find the average rate of change, and then you set the derivative equal to that. This is similar. You're finding the average value, and you're setting the function equal to it. So I'm going to do what I talked about in the video is store it, STO, and then give it a letter. I'm going to give it A or D, whatever. It doesn't matter. The letter doesn't matter. Click enter. Then we're going to put D here. Not I, D. Right? And then make sure we're on the right interval. Make sure my window's right. So I need to be going from like 1 to 4. And see what it looks like. I don't think my Y. Make sure your Y. This is another problem. Make sure your Y is big enough so that it includes it. See how my Y max is only 5? It needs to be like 10, at least 12. I mean, it needs to be at least 10, but I'll do 12 just so I can see it clearer, so that I actually see the 9.8 come up. And okay, here we go. And this is also important. Intersect, move it over, enter, enter, enter. 2.497. See that? 2.497. The thing is, guys, I can't just suddenly put down here k equals 2.497. This is the problem that I was experiencing on the last test, where there was this number that you guys were getting, and I was like, well, where'd you get that number? Like it was on the rate in, rate out question on the candidates test. Everybody made this mistake. Nobody told me how they got it. You have to say what you're doing on the calculator, even though you can't, like, obviously you can't show this. You're not going to draw the picture. You're saying what you're doing. What I'm doing right now is I'm setting g of k equal to 9.876. Like that's what I'm doing, right? And that got me to k equals 2.947. Sorry, 2.497. Okay.